Welcome family, this is tutorial part 3 all about torsional flexibility check from 4 pre-designed checklists for 20-story apartment. In the previous 2 tutorial parts, we have seen that the damage limitation and global stability index, and finally we have prepared Excel design a checklist together. Today I will show you torsional flexibility check on CSI ETABS program as per Eurocode standard. Watch up to the end and don't forget subscribe the channel, like this video, and finally drop any comments, maybe your question or suggestion. Thank you for your support. Let's start today's tutorial. Welcome viewers again. This is the 3D model that we are going to check for torsional flexibility in CSI ETABS program. So let's minimize this 3D model and let's clarify all the parts of this Excel template sheet for simply checking of torsional flexibility of this product. Then you can classify our building. Okay, so let's minimize it. After that, let's zoom the Excel template sheet. So it's enough. From this, the story of our project is listed like this. After that, we are going to apply this force, that is Fx, force in x direction, force in y direction, and that of rotation or torsion in the z direction to our model. So after applying this force at center of rigidity of our project, we can get displacement, displacement from CSI ETABS program. After getting this displacement, so using this force and displacement, we can calculate the stiffness of our projects like this. After calculating the stiffness of our projects, we can calculate torsional radius of the projects, that is Rx and Ry. After getting the torsional radius, we can go to calculate that of radius of gyration. So simply you have to compare radius of gyration and that of torsional radius. Then you can suggest or you can conclude your torsional flexibility or your classification of the project that made. So we can do all this together. So the first step is that you have to get or you have to calculate that of center of rigidity using CSI ETABS program. After that, we can calculate all this data. So after calculating torsional radius, that is Rx and Ry, you have to calculate also that of radius of gyration. Yes, radius of gyration using that of inertia and floor mass from your ETABS data. After calculating all this data, you have to get that of radius of gyration. So if that of torsional radius, that may be in x or y direction, that means Rx, let's take radius of or torsional radius in x direction, that is the Rx values. So you have to compare Rx value greater than or equal to that of radius of gyration. So if this condition is fulfilled, your project is not flexible. If not, our project is torsionally flexible. That means we can do all these things together. So let's remove all these data first. Let's remove it. After deleting all this data, let's go to apply all these 3 forces at center of rigidity of our model. So to do this, let's go to the ETABS program. From this, our model is locked, that is the analysis is completed. So let's go to the display menu here. From this show tables. So from the show table menu, let's go to the structural outputs here. From these other output items, so let's click center of mass and center of rigidity. After that, make it okay. So the center of mass and center of rigidity is paired like this. So let's check the story arrangement. So it's in reciprocal way. Don't worry about this. Let's copy the center of rigidity in x and y direction. So let's copy it. Let's open our Excel template sheet. Let's paste here. You have to make it in a reciprocal way. Okay, let's make it 1, 2, sorry, yes, From this, let's drag it to bottom. Let's sort it. So let's sort from largest to smallest. After this, when I click on expand the selection, this data will be reversed. So let's make it sort. So look at it, it's reversed. After that, this is the center of rigidity in X direction, and this is the center of rigidity in Y direction. That means using this data, let's go to apply all the force in our model. Okay, so let's make it done. After that, lock our model. Yes, lock our model. So let's go to the define menu from this load patterns. So from the load pattern, so this is the model that we're going to use before. So let's delete all this data. Then we're going to apply again. Okay, let's delete all these data. Let's delete. MZ delete. Okay, let's go to define all this load. Make it fx. Okay, from the load type they want to apply as a lateral load, so let's make it seismic drift. After this, let's make it add. Okay, let's make it add. So let's modify it. So from this, I want to apply as a user load. Yes, a user load. So let's modify it. Modify to this lateral load. Okay, from this, all the story is defined like this. After that, let's check the diaphragm, the roof. The diaphragm is a roof and the fifth floor. So let's uncheck this box, that is apply load at a diaphragm or center of mass. I'm not applying the load at center of mass. I'm going to apply at center of rigidity. So let's copy the center of rigidity in X direction. Okay. So this is the center of rigidity in X direction. That is good. After that, let's paste the center of rigidity that we are going to apply this force Fx. Okay, so let's copy in Y direction. So this is the coordinate for center of rigidity. After deciding the coordinates of center of rigidity in X and Y direction, in Fx, you have to apply any load here. So let's copy it. Let's use 1000 kilonewton. So let's copy this load. You can use any load. Let's copy all these loads. Yes. Let's copy. So let's paste here. Fx is defined like this. So let's make it okay. After completing the force in X, let's proceed to define the force in Y. So from this, let's make it add. And let's modify it. So let's uncheck this box as usual. So let's make it okay, and let's copy the load from X. So let's modify it. Let's copy all these loads. Copy it. So let's proceed to the 14Y. So you have to apply here 14Y. Paste it. After that, let's copy the coordinates, that is the center of rigidity coordinates. So let's modify it. Yeah. After that, let's copy it. Make it okay. So let's modify it. This is the force in Y direction. So let's add the force in Z direction, that is torsion that may be. So RZ or MZ. So let's make it add. After that, let's modify the load. From this, let's uncheck this box. You have to apply the coordinates like this. After copy the coordinate like this, you have to apply the force here. So let's copy it. So let's copy the force. Make it copy. Okay. So after that, let's paste here. Make it okay. So let's cancel all this data. I don't need all this data. So let's go back to the model, make it okay. So let's run the analysis. The structural analysis is completed like this. So let's go back to the Excel design template sheet, and then we are going to insert all the input data. That may be the force. So using this force, we are going to calculate the displacement. Then using this displacement and force, create stiffness of the building. After that, using this stiffness of the building, we can calculate torsional radius as Rx and Ry. So let's insert the applied force in X direction as 1000 kilonewton, in similar way to the Y direction, and to the Z direction as torsion. So we're going to insert all this input data. So using this force, we're going to calculate the displacement. So let's go back to the ETABS model. So let's go to the display option here from this show tables. So from the table data in the analysis result option, let's go to the joint output from this displacement. Then let's click on here, that is diaphragm center of mass and displacement. So we're going to select the load pattern. So let's select the load pattern that we are going to apply. So fx, fy, and that of mz, make it okay. After that, I don't need any load combination and load pattern here. Let's make it okay. So the displacement in fx, fy, and mz direction is displayed like this. So let's filter it. So let's make it fx. So the displacement in x direction in millimeter is like this, from roof to the last basement. That means let's copy all these displacements, make it copy. So let's paste here. Since the unit is in millimeter and the data that I need is in meter, so let's divide this data to 1000. So let's drag it to the bottom. So this is my displacement that ETABS software is calculated to me. So let's input the displacement in other direction in similar way. So let's go to the ETABS file. Let's change to fy. So this is the displacement. This is the displacement. So let's copy it. Let's copy it. So let's paste here. So this is the displacement. This is the displacement in y direction. Let's copy. So let's paste here only the value. So let's copy the displacement in the direction, that is RZ. So let's change the type here. Let's change the type here. So let's copy it in rad. Let's copy it in rad. Ctrl+C on your keyboard. Then let's copy the value here. Before proceeding to the next step, let's cancel all this data. After getting the displacement due to the applied force that we are going to apply on our model, so we can calculate stiffness of the building, that is kx, ky, and kt. After getting all this data, you can calculate rx and ry. So let's cancel all this formula. So kx, as per Eurocode standard, it's equals to, that is the stiffness of the building. That means it's equal to the applied force in x direction divided by that of the displacement in x direction. Okay. So in similar way, you can drag all this formula to the kt, that of ky. That means. So let's drag to the bottom again. Let's drag to the bottom in similar way. So let's drag it Let's check the formula. Okay, that's good. So after calculating the stiffness of the building, let's proceed to calculate torsional radius, that is in x and y direction. Let's make it is equals to the square roots of that of kt divided by the ky for rf, that means. So let's drag it to the bottom. Let's drag it to the bottom, and that of ry, it's a simple, which is equals to square roots of, let's click on square roots of kt, it's not changed, divided by that of kx. So make it okay. That's good. So let's drag to the bottom. So all the value of rx and ry are calculated like this. But you have to calculate the radius of gyration to compare with torsional radius. Okay, let's calculate the ls, or radius of gyration, that is the square roots of ip, or polar moment of inertia, with that of the floor mass. That means simply that of ip and m are calculated from ETABS software. So let's go back to the ETABS. Let's make it okay. So let's go to the display option here, show tables. So from this, let's uncheck this box. So let's go to the modal definition here. Click on other definitions from this mass data. Yes. So let's click on the mass summary by story, and that of mass summary by diaphragm. Make it okay. So all the mass and that of mass of moment of inertia is displayed like this, but the unit is in ton. So let's copy the mass, or that of the mass moment of inertia, or IP, in ton. Okay, let's copy it. So let's copy it. Let's copy here. So our moment of inertia, or the mass in moment of inertia, IP, is in a ton. So I want in kilogram. So you have to multiply this data by 1000 to change to kilogram. So let's drag to down. Let's copy it. So the IP value is displayed like this. So let's cancel all this data. But I need the mass, or the floor mass. So let's go back to the ETABS. So the floor mass in x and y is displayed like this, and it's nothing, but you can take one of this data. So let's copy it. Let's copy it. So let's paste in this data. So let's paste here. After that, you can calculate ls, that is the square roots of ip divided by m, which is equals to, let's make the square roots of polar moment of inertia divided by that of mass. Yeah, this is the value. This is the value. So if Rx greater than or equals to Ls, our project or our model is not torsionally flexible. Otherwise, it's flexible. That means if Rx, that is this value, that means K6 greater than or equals to O6, yeah, greater than or equals to O6, yes. So our model is not flexible. Otherwise, it's flexible. So let's make it okay. So using all this formula, you can check the flexibility conditions of your model in similar way toward the y direction. So you have to compare the values of ry with that of ls. Okay, so if ry is greater than or equals to ls, the project is, or your model is not torsionally flexible. Otherwise, it's flexible. So in similar way, let's check it. If L6, so if L6, that means this value, that means, yes, this value Ry is greater than or equals to O6, that is, let's check O6, that's a less value. so it's not flexible, otherwise it's flexible. So in similar way, you can drag it to the bottom. So our project is torsionally flexible. You have to classify your building as per Eurocode standard, and then you can decide to the behavioral factor. If it's irregular, you have to take 2 times 80% to calculate that of your behavioral factor. That means. So this is all about today's tutorial. Don't forget to subscribe my channel, like this video, and share to your friends. Have a nice time. Goodbye.